Assalamualaikum and salam sejahtera to the very dedicated lecturer, Dr. Muhammad Fauzi bin Mamat. Today we would like to present our second group project about water quenching medium. Without wasting much time, we will start the presentation by introducing ourselves first. So this is my group members. First we have Muhammad Hariz Zuhairi bin Arif. We have Muhammad Khairil Amri bin Dazri. Next we have Muhammad Syamil Akmal bin Ismail. And the last one we have Sofea Najihah Binti Yusof. This project we were given for 5 tasks, which is task 1 is sample preparation and heat treatment, task 2 impact test, task 3 tensile test, task 4 microstructure analysis, and task 5 is hardness test. So let's start with the task 1. These are among our most important engineering materials. A very important property of steel is the ability to alter its hardness by simple heat treatments. Treatments of steels is a hard treating process whereby the steels are exposed to an elevated temperature for a period of time and cool off, which transforms and or change the mechanical properties without changing the product shape. Common heat treatment processes is annealing, normalizing, hardening, which is quench and temper, and hardening. This is the equipment used for the task 1, which is use laser cut machine, furnace, a very long tongs, materials which is plain carbon steel, and water for quenching. Treatment procedure. So the first step is specimen preparation. Next step, alternization process. Next, quenching process. The last one is cooling process. Specimen preparation. Cutting the specimen into one-thing shape using laser cutter machine. Alternization process. Place the specimen into the gas furnace. The specimen to austenization temperature and hold according to the soaking time. Quenching process. Use different type of quenching medium. So our group is water. Immerse the specimens into the quenching medium for rapid cooling processes. Cooling process. Heat the oven to 900 degrees. Heat the test piece for 45 minutes. Change the test piece into water. Cool it until normal temperature. Estimate 24 hours. So this is the results of our specimen. Specimen for impact test, tensile test, and hardness test.
Task 2. Impact test. Impact test determines the amount of energy absorbed by a material during fracture. This absorbed energy is measure of a given material's toughness and act as a tool to study temperature-dependent brittle ductile transition. It is to determine whether the material is brittle or ductile in nature. Here are the equipment. First, we need untreated Chappie specimen, Instron impact test machine, and treated Chappie specimen. Safety precaution. The impact apparatus can cause injury, therefore keep away from the apparatus as the pendulum is released. Raise the pendulum to its high position just before testing. It should not be locked at the high position any longer than necessary. The person who placed the notch bar sample into the tester must be the one who released the pendulum. This is to ensure no one's hands at the sample placing area. Impact test procedure. Step 1. Power up the equipment. Step 2. Calibrate and positioning hammer. Step 3. Setting the parameter. Step 4. Setting specimen. Step 5. Positioning hammer for impact test. Step 6. Place the specimen on the anvil. Step 7. Close protective cover. Step 8. Release the hammer. Step 9. And last, record impact energy. Here are the results for impact test. The impact test result shows that both material break at a certain impact force. Heat-treated material are much stronger than untreated material. Task 3. Tensile test. Tensile testing, also known as tension testing, is a fundamental material science and engineering test in which a sample is subjected to a controlled tension until failure. Properties that are directly measured via a tensile test are ultimate test strength, breaking strength, maximum elongation, and reduction in area. Some materials use biaxial tensile testing. The main difference between this testing machine being how load is applied on the materials. Here are the equipment. We need the Shimazu tensile test machine, untreated tensile specimen, and treated tensile specimen. For tensile test process, step 1, open the software trapezium. Step 2, setting 0 as software. Step 3, setting specimen aligned with clamping device. Step 4, adjust the manual button to automatic button. Step 5, click start to run the machine. Step 6, wait until the specimen snap. Step 7, unclamp and remove the specimen. Step 8, save the graph result for the report. And here's the result for test specimen. You can see the untreated and treated results. And here's the result graph. The tensile test result shows that both materials break at a certain force. Heat-treated materials are much stronger than untreated materials.
Okay, for the task 4, microstructure analysis. For introduction, the microstructure of a metal specimen is revealed by a surface treatment using an appropriate chemical reagent in a procedure termed etching. The prepared sample is then examined using optical and inverted microscope based on visible incident light, grain size, and average grain diameter of the material may be determined using the photomicrographs obtained by this technique. Okay, for there are 7 equipment in this task. For the first is abrasive cutting machine. Second, ultrasonic valve. Third, hot mounting press machine. Fourth, optical microscope. 5, polisher and grinder machine. 6, hand dryer, and the last one is inverted microscope. Okay, this is the equipment for running this task. There are 7 equipment in this task. First, plain carbon steel PCS, test pen, notepad, and micropad, polishing cloth, abrasive paper grid, sequence 0.05, alumina, nickel, diamond suspension, and lastly is colloidal silica. Okay, this is the microstructure analysis procedure. Specimen preparation, mounting process, grinding process, polishing process, cleaning process, etching process, and lastly is microstructure examination. Okay, for the specimen preparation, we have to cut specimen approximately 15 mm diameter uh, by 10 millimeter thickness of plain carbon steel PCS for one specimen. And then this is the mounting process. Step 1, we have to read the SOP of hot mounting machine. Step 2, we have to power up the equipment. Step 3, we have to set machine parameter. Step 4, we have to insert alumina powder with specific weight. Step 5, we have to clamp the top and start mold making. Step 6, Wait till the machine make a stopping sound. Step 7, stop machine and take out the finished mounting. And lastly, we got the finished mounting specimen. Okay, this is grinding process. Grind the surface of specimen manually with abrasive paper grid sequence 120, 240, 320, 400, 600, 800, and 1000 in one direction and rotate 90 necessarily. Use only dedicated abrasive paper for PCS. Set the grinding wheels at set the grinding wheels at 180 RPM. For the grinding time uh, for 1 to minutes. Grinding process procedure. Step 1. Open water line, locate behind grinder or use spray distilled water. Step 2. Starting with the lowest number of grid, example 120 or 240. Step 3. Place prepare specimen with metal face down of abrasive surface. Step 4. Slide specimen against abrasive in a forward and backward motion or circulating mode. Step 5. Clean metal face with distilled water. Step 6. Next, turn specimen 90 degrees and repeat above procedure on the next higher number of grid surface. Step 7. Clean metal face with distilled water. Step 8. Again, turn specimen 90 degrees and repeat procedure 2. Now on the next higher number of grid surface. Step 9. Clean metal face with distilled water. Step 10. Finally, turning specimen 90 degrees and repeat procedure 2 now on the highest number of grid surface. Step 11. Clean metal face with distilled water. Okay, for the polishing process. Polish the specimen on polishing wheels using suitable liquid suspension and polishing cloths until a mirror-like finish is obtained. At this stage, the microscopic examination may reveal cracks, seams, non-metallic inclusions, and any other similar scale in homogeneities. Set the polishing wheels at 180 RPM. For the polishing time, 1 minute to 2 minutes only. Use only dedicated polishing cloths for each suspension. Spray only small amount of suspension. Okay, polishing process procedure. First, start polishing with 6 micron and then with 3 micron and then proceed to 1 micron grid size of diamond suspension. Final, final polishing with 0.02 micron colloidal silica. For the second process procedure, use test pen polishing cloth for 6 micron diamond suspension. Third, clean metal face with distilled water. Number 4, use test pen polishing cloth for 3 micron diamond suspension. Spray only small amount of suspension. 5. Clean metal face with distilled water. 6. Use napped polishing cloths for 1 micron diamond suspension. 7. Clean metal face with distilled water. 8. Use micropad polishing cloths for 0.0 micron colloidal silica. 9. Clean metal face with distilled water. For the cleaning process, Step 1. Immerse the specimen in the ultrasonic water bath. Step 2. Set the machine parameters as following below. For the time, 300 seconds. For the temperature, 35 Celsius. And lastly, sonic frequency, 16 Hertz. And for the step 3, dry the specimen.
Next is etching process. Note, it is very important to not over etch or under etch the specimen. Step 1. Immerse PCS in nitrile for only 10 seconds. Step 2. Thoroughly rinse the specimen under running water. Step 3. Dry the specimen. Next, microstructure examination. Step 1. Select objective lens with 20 times and 100 times magnification respectively. Step 2. The sample is placed on the stage. Step 3. Adjust the brightness. Step 4. Adjust the longitudinal knob to move the stage in order to adjust the specimen. Step 5. Focus is adjust by moving the objective lens along the vertical axis to bring it closer to or further from the specimen. The focus mechanism typically has a dual concentric knob for cause and final adjustment. Step 6. Find the best image. Step 7. Study the microstructure of each sample. Step 8. Use inverted microscope for capture image using 20 times and 100 times magnification. So this is the result. Uh, photomicrograph of untreated specimen and photomicrograph of treated specimen. And the right, this is 100 time and 500 time. Next, task 5, hardness test. Hardness is the resistance of material to localize deformation. Hardness measurements are widely used for the quality control of material because they are quick and considered to be non-destructive tests when the marked indentation produced by the test are in low stress area. Rockwell hardness test. The Rockwell tests differ from the Brinell and Vickers test in not obtaining a value for the hardness in terms of an indentation but using the depth of indentation. This depth being directly indicated by a pointer on a calibrate scale. The test uses either a diamond cone or hardened steel ball as the intender. This is the equipment. Using Rockwell hardness testing machine, copper alloy, plain carbon steel, mild steel, aluminium alloy, and sandpaper. Specimen preparation procedure. Step 1. Grind the surface of the specimen if possible. Otherwise, smoothen the surface with sandpaper and polish the part to be tested. Step 2. Make sure the surface is flat and smooth. Step 3. Ensure the test piece is clean from any oil, grease, or rust. Next, Rockwell hardness test procedure. For start, turn on power machine and then set the total load sequence which to the auto position in the side panel. Next, set the minor load from selector running to as Rockwell specification or R Rockwell. Next, fit the desired intender. 5. Place specimen on the anvil. 6. Set total load value by turning selector knob. 7. Preparation complete. 8. Apply manual load by adjusting an anvil until the intended touch specimen. 9. After appropriate minor load is applied, minor load application is complete. 10. Press the start switch. The measurement process will be automatically performed. The continue for Rockwell hardness test procedure, presetting, and then during total load application and during total load removal. Next, measure option, and after that read and record the hardness value from the hardness indicator. After that, turn on elevating handle in the reverse direction to lower the anvil and remove the specimen. And lastly, repeat this 3 to 16 step for other method and specimen. So this is the result for Rockwell hardness test. We can see plain carbon steel using hardness test HRC and others using HRB. Softest to hardest material based on the result start from copper alloy, aluminum alloy, plain carbon steel, and lastly mild steel. Next. The conclusion is heat treatment are associated with machining in the sense that it will help with multiple applications such as tool and material. The heat treatment task was a quench in water bath and have demonstrated the key feature of impact test, tensile strength, hardness test, and microstructure with its result. We can conclude that treated specimen with water quenching medium can affect the result of the outcome by strengthening the material compared to untreated specimen. So that's all from us. Thank you very much.